So sometimes we have rational expressions that don't have common denominators. So you might remember in your past something like 1 over 6 plus, 5 over 12, and you wanted to add those fractions, but you had to get what they said, a common denominator. And so when you have something like this, in this case you have 6 and 12, you have to think of the smallest number that both 6 and 12 will go into, and that's going to be what we call the least common denominator. And so you might think in this case, and we abbreviate it LCD, in this case it's going to be 12. So a lot of times I like to write the LCD over to the side so I can remember what I'm trying to get. So in the first fraction here, you'd have to multiply by 2 to get that denominator to be a 12. But you can't just multiply the denominator, you also have to multiply the numerator by the same thing. And the rules of fractions say you can multiply by whatever you want as long as it's not 0, and as long as you multiply the numerator and the denominator by the same thing. In fact, we did that in the last video where we multiplied by -1. Okay, so then I get a new fraction, 2/12 for that first fraction. Now that's not simplified, but that's okay. We call it building fractions because we're trying to get at what we call a common denominator. And so now we have 2/12 plus 5/12. Now we can add the numerators and get 7/12. And so that's how we did it when we were working with fractions. Now we're going to apply those same ideas to rational expressions. So in this first example, they say find the LCD for the expressions. So I have 2 over, I'm going to factor that trinomial right there. So again, practice your factoring, but it's going to factor into x minus 4 and x plus 3. So I've been factoring many years, and that's what it is. Okay, then I want to do the same thing with the other denominator. 1 over, now that's the difference of squares, so it's going to be x plus 4, x minus 4. Okay, now I can look at what will be in the LCD. So the first rule is when you're trying to get a common denominator, you're going to factor those denominators. All right, our LCD, we're going to need an x minus 4, we're going to need an x plus 3, and then we're also going to need an x plus 4. So you're kind of comparing the denominators. You can think about taking both factors or all the factors in the first denominator, and then you simply add in what's missing from the second denominator. So I started with the x minus 4 and the x plus 3, wrote those down, and then over here I'm looking at this denominator. I'm saying, well, I need an x plus 4 because I don't have one. I don't need another x minus 4. 1 is enough. So that's great. So that's going to be the LCD. If you have more than 3 binomials in your LCD at this point, I'd be a little suspicious because these get really large. I mean, they could give you something like that, but anyway, we'll see some more examples. So that's the LCD. In other words, that's what we're trying to get. Now, that means I'm going to have to multiply this first term. If I want, part B says rewrite them as equivalent rational expressions with the lowest common denominator. So I want to try to take that first expression. I'm going to have to multiply by an x plus 4 in the top and in the bottom. That's what will give me the LCD. On the other one, I'm going to have to multiply by what's missing, x plus 3. So you kind of look at them and say, what's missing in the denominator? What do I need to multiply by? Okay, so I'm going to go ahead and go to part B now. I'm going to go ahead and distribute the numerator out. So I'm going to get 2x plus 8 over, I won't multiply out that denominator. I'll just write it. X minus 4, x plus 3, x plus 4. It doesn't really matter what order you put those binomials in. Okay, in the other numerator, I'm going to distribute the 1. So I get x plus 3. And then the denominator is x minus 4, x plus 3, x plus 4. So now we've rewritten the two terms, and now they have common denominators. It doesn't ask us to add or subtract them, so we're just going to stop right there. I'm sure the next problem we'll get to do that.